Hello everyone, welcome once again to my channel, and this is the third video on Kubernetes 101 and it's on services. In the previous videos we have seen that how you can actually launch your application as pod on a Kubernetes cluster. So in this video we are going to learn how you can expose those applications to the outside or within that cluster as a group of application or as a service. So what actually a service is? So it acts as a barrier or it acts as a logical encapsulation on your pods, which is a set of applications. So as you know, the pods are ephemeral in nature. So if one of the pod dies out, what happens is if another pod needs to interact with that, it won't be able to access it. So in Kubernetes, there is a provisioning, there is an object which helps you with the abstraction of those pods altogether in the form of a specific object called service. Service encapsulates them, and in case any other application needs to access those pods, they can access those service, and accordingly the mapping of internally of those traffics to those specific ports where your application is running on that pod, it would be distributed accordingly. Okay, so it's nothing but another kind of object that Kubernetes provides. So there are different ways where you can actually expose your services, your applications through different kinds of services that are provided. So I will talk about them in the upcoming slides, but let's try to see how this interaction takes place. Okay. So first of all, let us imagine there are two set of pods. Okay. One is the one on the left side that runs 3 replicas, and it is marked with a label key1 equal to value1. Say the container image that is running is a Tomcat or an Nginx. While on the right, you have another pod which is labeled as key1 equal to value2, and only a single replica of that is running. And you are, say for example, you are running another application which is hosted possibly in a shell or a bash image. Okay, now you want to create a service, or you want to expose the replica of 3 or those pods application to an external client. So how it is done? So you need to create a service object. I will show you how the service object creation takes place in Kubernetes, definitely through the manifest and the other way, the CLI way, which we learned, the declarative and the imperative way. So what happens is when you create a service object, you need to specify in the terms of selector that which pod it is mapped to. So once you create a service for the specific pod, through the selector you specify, okay, this is where I'm going to route those traffics that are coming towards me. So key1 value1 is the selector, that's the service on the top. It's while creating we are specifying, and it kinds of creates a mapping that, okay, so whatever request I'm going to receive, I will going to send it to the pod sets on the left side. So next time when a traffic comes, hits it, it redirects it to one of the available pods. So services main features, it's like a proxy that it's create in front. So it also has the capability of load balancing, and also due to the ephemeral nature of the pods, that is also being covered by service. So instead of accessing directly to a IP of a pod, you access it through a service name. So coming to the different types. So the first type of service is a ClusterIP. So ClusterIP, it's kind of a default set, default configuration whenever you create a service. So whenever you create this kind of service, what happens, an internal IP address is assigned to that specific service, to that specific object, and that is only accessible within the cluster. So if any other services are available, they will be, or on any client that is running within the cluster, any entity, it would be able to access that service, and it would be able to get the response from the backend corresponding pods that the services bind to. A typical example of then why do we need this kind of service that we are not exposing it? So imagine a typical scenario where you have a certain set of front-end pods, and you have a back-end pods, and you have a database or Redis pods. Okay, so with ClusterIP, what happens, the web app, in case they need to interact with the backend, or the backend they in case need to interact with the database or the Redis pod, they will be directly accessing that specific service that we create. Say for example, for backend pods, we have created a backend ClusterIP service. So all the web apps would be sending requests to the backend service, and the service would be actually taking care of that corresponding load distribution among the backend pods. Same goes for the Redis or the database tier as well. I will show you the demonstration how it works in the lab, which is at the end of this session. Next is the NodePort type. So by default, it creates the service type that is created is cluster IP. But what do you, in case you need to expose this service to an outward traffic or an external traffic, that is achieved with the help of NodePort, and definitely there are other mechanisms as well. But in NodePort, what happens? The very node where your workloads are running. So one of the port between 30,000 and 32767 range is opened, and that specific service can be accessed through that port. So that means in case an external candidate needs to access that service with the help of node IP, that is the public IP of the node, and or the private, depending upon how the network you have defined. So with the help of the node IP colon the node port, it will be accessible. So the entire traffic part, like how the whether the externally candidates they are able to access the node or not, that kind of configuration needs to be pre-established first before using this kind of configurations. Moving ahead with the service type load balancer. Well, this is kind specifically it is applicable whenever you are moving with a cloud based solution. So in case any kind of cloud providers, like in case of Amazon EKS. So what happens is you can use this kind of specific load balancer type service. So the cloud provisions actually provisions a load balancer on your behalf, and that load balancer actually gets binded with this service, this kind of service type, and with that load balancer actually you can distribute the load among your pods. Okay, there's another type as well, external, but I'm not going into the depth of that. But in case you need to know any kind of details, you definitely refer to the Kubernetes documentations. So I will move ahead with the demonstration part now. So this is what our Killer Coda console is about, and this specific tutorial is about how you create a service and what are the different types of service. It basically gives you a basic hands-on. Okay, so I will share you with the link. Let's start this. Okay, so this lab comes with certain predefined YML manifest files. So first thing I would like to show you is how this is nothing but an Nginx deployment, which we earlier talked about. It creates, but let's try to discuss the three different kinds of services we have. Okay, first is the default one, which we talked about, right? The cluster IP. So let's enter into the cluster IP YML and see how the things are. So kind, API version, the name, everything is fine. Okay, and even the spec, you can see the selector is app nginx. So once I launch the deployment, that is the pods, my pods will have this specific label app equal to nginx. So it's specifically selecting, okay, these are the pods I'm going to serve. By default, there's no specific service type tag you will be observing in this YML manifest. So only thing is you are seeing, okay, for the ports, the protocol is TCP, and the very port of this service is 80 and the target port is 80. So target port means the port which is associated with the pods, and the simple port that it talks about is the port of the service. Okay, so any request that is coming to services port 80 would be redirected to pods port 80. That's what the understanding is. So let us exit. We will first then create the deployment, and let's see whether our deployment is healthy or not. Yes, our deployment is healthy. And what we shall do is, and basically you can go to the next, and the documentation is this. So on the left side, it's already there. Just apply it. Uh, I'm so sorry. There's a typo over here. Just ignore. So if I click on kubectl get service -ovide, it gives more information about the services that are created. So you will find over here the cluster IP nginx, and this is the cluster IP which is internal to this specific cluster. And let me try to access the application using the curl command. And this is the IP, which is basically the cluster IP. And if I try to access it, this request has been processed by host this. So let's try to, so this is what the pod is, and the request has been, so I made a request to this specific cluster IP, which is cluster IP nginx service, and I received this response. Okay. And this response came from the pod that we have. Next, let's try to describe the service and see. So the type you will find here is, it's the cluster IP type. Okay. And there are various other informations that are available regarding the IP, the associated IPs, etc. So if you want to play around this and try to understand how things work over here, you can definitely do through this various playgrounds. Next demonstration, we will move into how a NodePort works. Okay. So here we have already have a YML, right? So you won't find any specific difference between the previous one, the cluster IP one, and the NodePort. The only thing is that the type here is NodePort. Okay. The type here is NodePort, and while you create this, a specific IP from the range 30,000 to 32767, that range, from that a specific IP is selected and automatically assigned for this specific service. So what we shall do, let's try to create this. So this is created. Let's try to see. Okay. Now you will find that though the NodePort over here, it also gets by default a cluster IP. Okay. And but the check over here is, there is another IP, there's another port that you will observe, which is within the range that I specified for NodePort ports. Okay. So which is 3922. So if somebody wants to access this port, how he will do that? So let's try to get hold of the node details. So we have two nodes. One is the control plane node, another is the node 01. And this, we are talking about this specific service that got created. Where it got created, we can, it's actually the pods that are created are in node 01. So let us try to access. So before that, let's verify which type of port that specific service is. And next what we shall do, we'll do a quick round of testing, which is curl http colon double slash. And if I give node 01 colon, and the port is 31922. And you see with the node port, the node IP, which is basically just denoted by the node name, colon 31922, I'm getting a response from my backend pod. The next setup that we have, which is of type load balancer, would not work well in this kind of setup here. So it is worth that if you are kind of playing around with any cloud-based Kubernetes platforms. So if you're using Amazon EKS, for example, it is worth trying over there. So I will show you the manifest file of the load balancer service. So you see the type here is load balancer. Okay, that's the only difference over here. But what ideally it would do, let me try to create. So there is, in case you want the load balancer type service to work on this Katacoda platform or Kilicoda platform, the only thing is that it's going to do some kind of mimic over here by creation of certain deployment daemon sets and deployments. But I'm not going into the depth of this. However, I have tried and tested out, it's not kind of working. But this is what the service it is creating. And if I click on kubectl get svc-o-wide, you will observe that the type is load balancer and external IP is pending in this case. So ideally what happens is, instead of pending, you are supposed to get a DNS record of a load balancer over here. And while hitting on that load balancer, you will be able to get hold of you will be able to actually access the endpoint. However, unfortunately, this is not getting created in this kind of platforms. But yes, if you are working with cloud-based environments, you will be able to do so. So that was all about the three kind of services. Time for a quick hands-on over here, an exercise. So what the exercise talks about, let me zoom in a bit. Okay, create a deployment in the default namespace with HTTP image and name the deployment as SP Cloud, expose it as NodePort, and then try to access it. Okay, so let's try to do that. So first thing, in order to create a deployment, first we need to create a deployment, right, before going ahead with creation of NodePort. So kubectl run, and the name it has asked for is SP Cloud, right? SP Cloud, and hyphen image is HTTPD. Okay, right? And what we shall do is we shall just simply create it. So a pod is created for SP Cloud. So K is kind of a short that if you have a specific alias, K denotes kubectl. I would use K for my feasibility over here. So you see my SP Cloud, it's working over here. Okay. Now I need to expose it with the help of a NodePort type service. So what I shall do, expose pod. So in case you want to know the expose command, so k expose help hyphen help. So this is the command that I'm trying to use, which is expose deployment nginx, this specific command I'm trying to use. But since it's not nginx for us, it would be something else. But let's try to do that. Okay. Sorry. But we need to make some changes, right? So the deployment name that we used over there is SP Cloud. SP Cloud, that was the deployment name, and let's try to give, if we can give a name. The name we were asked is SP Cloud hyphen SVC, and the port is 80, target port is 8000, say for 8, target port is also 80 for example. And what we shall do is hyphen dry hyphen run equal to client, and hyphen o yml, and we're going to save it in a SVC. Okay, deployment SVC not found. So let's see what deployment name is there. Okay, the deployment name is nginx. Oh, I believe we did something wrong over here. So let's try to see what we did wrong. So the main mistake which I made here is I'm running SP Cloud pod, but it asked me to create a deployment, right? So let's try to delete this pod. So I have deleted this pod. Now I will create a deployment. So these are just a shorthand that I'm using, create deploy. And in the deployment, what it has to be in the default namespace. So what's the name that I should give? SP Cloud. Okay. And hyphen image is equals to HTTPD, and nothing else. Let's go ahead and create. So get deploy. So SP Cloud is deployed. Okay. Now what shall we do? We have to create a service, right? So let's go back to the old command which we created, and okay, SVC Cloud. Okay, this is what we have got, right? This is what we actually captured with the help of the commands that we used. Now the only thing that we need to add over here is, so don't get confused with the status load balancer equals. So just I can remove it, it's not necessary. So every time a pod is restarted or anything that happens for a specific service, so those kind of details get introduced over there. Just ignore for now. So here I will specify type is equals to NodePort apply-f svc.yml. Just a second. Also, the name needs to be changed. Name is SVC Cloud, right? Let's just revalidating. Yes, okay. Okay, apply-f svc.yml. And the service is created. Let's try to see what are the services. So as SP Cloud SVC, it's a NodePort that is available, right? Now let's try to access the service. Curl HTTP, we know node 01, and the port is, as you can see, 30911. It says, okay. And it says it works, right? This is what the response is expected. So things are all fine, it seems. Let's try to check if it, yes, congratulations, it worked. The validation was successful. Cool. So in this way, you have learned about different kinds of services. What are services? It's like an abstraction for covering the encapsulating the pods that you create. So it helps with multiple things, load balancing, as well as abstraction layer across surrounding the pods, as pods are ephemeral in nature. So we talked about different types of load balancer, different types of services, ClusterIP, NodePort, and load balancer, and even external type is there additionally. So depending upon what kind of interactions you want and how you want to expose it, you would like to wisely select ones. And definitely you get to do some hands-on, definitely do some hands-on on Killer Coda in case you're preparing for any kind of certifications, or and even you're preparing yourself for Kubernetes. I hope you like the video, and I will come back with another exciting videos on the other REST components that are remaining. Feel free to like, share, and subscribe, and put a comment in case you have any questions. Goodbye. Cheers for now.